When starting an electrical contracting business, selecting the right vehicle is a critical decision. An F350 with a utility bed offers several advantages, including large cargo capacity, excellent towing capability, and overall durability for hauling heavy materials. However, it also presents some downsides. It can be expensive to purchase and maintain, has poor fuel efficiency, and its large size can make it challenging to maneuver in tight spaces, especially in residential areas. Alternatively, a van provides a different set of benefits and drawbacks. Vans offer an enclosed cargo area, which provides secure storage for tools and materials, a more comfortable cabin for long days on the road, and generally better fuel efficiency compared to pickup trucks. On the other hand, vans typically have limited cargo capacity when compared to pickup trucks, and you might need to use a trailer for larger loads. When choosing a van, size and engine power are important factors to consider. For maximum cargo capacity, a full-size van such as a Ford Transit or Mercedes-Benz Sprinter is generally recommended. Regarding the engine, a V6 engine is often sufficient for most electrical contracting tasks. However, if you frequently handle heavy-duty work or need to tow trailers, a V8 or a diesel engine might be a better choice. Keep in mind that a half-ton van might not be adequate for the weight and size of electrical materials and tools. Now let's discuss the potential benefits of holding both an electrical contracting license and a general contractor's license. Having both licenses significantly increases your revenue potential. It allows you to bid on a wider range of projects, including larger-scale commercial projects that require comprehensive services. As a general contractor, you can subcontract the electrical work to your own electrical contracting company. This arrangement increases your revenue and profit margins, as you're essentially paying yourself for the electrical portion of the project. By offering both electrical and general contracting services, you can provide a more comprehensive solution to your clients. This can lead to stronger relationships, increased customer satisfaction, and repeat business. Consider a scenario where a residential electrical contractor obtains a general contractor's license. This allows them to secure a contract to build a new high-rise luxury apartment building. They can then subcontract the electrical work to their own electrical contracting company, generating substantial revenue and establishing a strong presence in the commercial market. As you weigh your vehicle options and business strategies, keep a few additional tips in mind. Firstly, carefully consider your daily work routine and the types of materials and equipment you will typically need to transport. This will help you determine the required cargo capacity and towing capability. Secondly, thoroughly research the fuel efficiency and towing capacity of different vehicle options to find the best balance for your needs and budget. Thirdly, seek recommendations from other electrical contractors or professionals in the industry. Their experiences and insights can provide valuable guidance. Finally, don't hesitate to upgrade your vehicle as your business grows and your needs change. Investing in a more capable vehicle can ultimately improve efficiency and profitability. Now let's talk about some specific electrical considerations for your jobs. Understanding overcurrent protection is critical. An overcurrent protective device, such as a circuit breaker or a fuse, is designed to protect electrical circuits from excessive current, which can cause overheating, fire, and damage to equipment. These devices are rated in amps, which indicates the amount of current they can safely carry before tripping or blowing. When selecting overcurrent protection, it is crucial to choose the correct amperage rating for the circuit it is protecting. This rating should be based on the ampacity of the conductors in the circuit and the load it is intended to serve. Exceeding the overcurrent protections rating can lead to dangerous overheating and potential fire hazards. Furthermore, it's also important to understand conductor ampacity. Conductor ampacity refers to the maximum amount of current, measured in amps, that a conductor can carry continuously without exceeding its temperature rating. The ampacity of a conductor is determined by its size, material, insulation type, and installation conditions. The National Electrical Code, or NEC, provides tables, such as NEC Table 310.15b16, that list the ampacities of various conductors based on these factors. It is crucial to select conductors with adequate ampacity for the intended load. Using conductors with insufficient ampacity can result in overheating, voltage drop, and potential fire hazards. Proper grounding is also essential for electrical safety. Grounding provides a low impedance path for fault current to return to the source, which helps to quickly trip over current protective devices and minimize the risk of electric shock. Grounding systems typically consist of a grounding electrode, such as a ground rod or water pipe, connected to the electrical system through a grounding conductor. All metal enclosures and non-current carrying metal parts of electrical equipment should be properly grounded. It's important to test grounding systems to ensure their effectiveness and to verify that the grounding impedance is within acceptable limits. Now let's move on to voltage drop calculations. Voltage drop refers to the decrease in voltage that occurs along a conductor due to its impedance and the current flowing through it. Excessive voltage drop can cause equipment to malfunction, reduce the efficiency of lighting, and even damage sensitive electronic devices. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. Voltage drop can be calculated using various formulas taking into account the conductor length, size, material, current, and power factor. It is crucial to perform voltage drop calculations to ensure that the voltage at the load is within acceptable limits. Here's some info on conduit fill. Conduit fill refers to the amount of space occupied by conductors inside a conduit. The NEC limits the maximum allowable conduit fill to prevent overheating and damage to conductors. The allowable conduit fill is typically expressed as a percentage of the conduit's cross-sectional area. The specific percentage varies depending on the number of conductors in the conduit and the type of conduit. The NEC provides tables and guidelines for calculating conduit fill. It is crucial to adhere to these requirements to ensure proper heat dissipation and prevent conductor damage. Lastly, let's talk about box fill calculations. Box fill refers to the amount of space occupied by conductors, devices, and fittings inside an electrical box. The NEC limits the maximum allowable box fill to prevent overcrowding and damage to conductors and devices. The allowable box fill is determined by the size of the box, the number of conductors, the size of the conductors, and the number of devices and fittings. The NEC provides tables and guidelines for calculating box fill. It is crucial to adhere to these requirements to ensure that the conductors and devices are not subjected to excessive stress or damage. Understanding these electrical considerations is essential for ensuring the safety and reliability of electrical installations. Always consult the NEC and other applicable codes and standards for specific requirements and guidelines. Furthermore, be aware of common wiring mistakes and take steps to avoid them. One common mistake is improper wire connections. Loose or poorly made wire connections can cause arcing, overheating, and even fires. Always use appropriate wire connectors and ensure that they are properly tightened. Another common mistake is using the wrong size of wire. Using undersized wires can result in overheating, voltage drop, and potential fire hazards. Always select wires with adequate ampacity for the intended load. Another common mistake is neglecting to properly ground electrical equipment. Improper grounding can increase the risk of electric shock. Always ensure that all metal enclosures and non-current carrying metal parts of electrical equipment are properly grounded. Another common mistake is overloading circuits. Overloading circuits can cause overheating, tripping of circuit breakers, and potential fire hazards. Always avoid plugging too many devices into a single circuit. Another common mistake is damaging wires during installation. Damaged wires can create short circuits and other electrical hazards. Always handle wires carefully and avoid nicking or cutting the insulation. Another common mistake is ignoring the NEC requirements. The NEC provides important safety guidelines for electrical installations. Always consult the NEC and adhere to its requirements. By avoiding these common wiring mistakes, you can significantly reduce the risk of electrical hazards. Let's consider safety tips when working with electricity. Firstly, always de-energize circuits before working on them. Turn off the power at the circuit breaker or fuse box and verify that the circuit is de-energized using a voltage tester. Secondly, use insulated tools. Insulated tools can help protect you from electric shock. Always use tools that are specifically designed for electrical work and that are in good condition. Thirdly, wear appropriate personal protective equipment. Wear safety glasses, gloves, and other appropriate PPE to protect yourself from electrical hazards. Fourthly, be aware of your surroundings. Pay attention to your surroundings and avoid working in wet or damp conditions. Fifthly, never work alone. Always have someone nearby who can assist you in case of an emergency. Sixthly, follow the NEC requirements. The NEC provides important safety guidelines for electrical installations. Always consult the NEC and adhere to its requirements. By following these safety tips, you can significantly reduce the risk of electrical accidents. Also, let's cover generator sizing for backup power. When selecting a generator for backup power, it is crucial to choose the correct size to meet your needs. An undersized generator will not be able to supply enough power to run all of your essential loads, while an oversized generator will be less efficient and more expensive. To determine the appropriate generator size, you need to calculate the total power requirements of the loads you want to power. Start by listing all of the appliances, lights, and other electrical devices that you want to run during a power outage. For each device, note its wattage. If the wattage is not listed, you can usually find the amperage and voltage and calculate the wattage using the formula watts equals volts times amps. Next, add up the wattages of all of the devices to determine the total power requirement. Keep in mind that some devices, such as motors, require more power to start than they do to run continuously. This is known as the starting wattage. When calculating the total power requirement, be sure to include the starting wattage of any devices that have motors. Once you have calculated the total power requirement, you can select a generator that is sized appropriately. It is generally recommended to choose a generator that has a slightly higher capacity than the total power requirement to allow for future expansion and to provide a safety margin. Lastly, let's discuss surge protection. Electrical surges are sudden increases in voltage that can damage electronic equipment. Surges can be caused by lightning strikes, power outages, and other electrical disturbances. Surge protection devices, or SPDs, are designed to protect electronic equipment from surges by diverting the excess voltage to ground. SPD are available in a variety of forms, including surge protectors, surge arresters, and transient voltage surge suppressors. Surge protectors are typically used to protect individual appliances or electronic devices. Surge arresters are typically used to protect entire electrical panels. Transient voltage surge suppressors, or TVSSs, are typically used to protect sensitive electronic equipment. When selecting SPD, it is important to choose devices that are rated appropriately for the voltage and current of the electrical system. It is also important to choose devices that are UL listed or otherwise certified to meet safety standards. SPD should be installed in accordance with the manufacturer's instructions and all applicable electrical codes. This detailed guidance should help in navigating the electrical contracting business.